Hey guys, it's Mr. Walker here, and yes, I am currently walking down the street in my neighborhood because no sooner had we finished one fitness challenge than Mrs. Walker decided to sign us up for another one. So I guess putting all those miles in on the bike wasn't quite enough, so here I am getting in some steps. Now, for this fitness challenge, it seems like we have to walk a certain amount of yards, right? And we're needing to walk about 5,280 yards, which seems like a lot. So, which is why I'm currently walking while I am filming this lesson for you. So, so far between today and yesterday, I was able to walk 287 yards each day. Okay, so I got 287 yards today, 287 yards yesterday. Miss Walker claims that she's gone at least 3 times as much of that, which I know is not entirely true, but that's okay, we'll go with it. So she's gone 3 times as much as that. So, I need to figure out how many yards we have so far and how many more we have to do in order to meet this next fitness challenge. And I'm kind of getting sick of all these fitness challenges, but it's okay, we're making it work. So we're gonna go in, we're gonna do some problem solving together. You guys can let me know who kind of works through some things together. See, I'm getting so tired, I'm getting tongue tied. So let's go do some problem solving in the virtual classroom, and then maybe we'll come back here and you can help me out. All right, guys, see you in a few. All right, guys, here we are back in the virtual classroom here. We're going to do some problem solving together for sure, because it's really important for us to get some practice at this, because this is something we're going to continue to see, not only in math class here, but in real life. Most of your math problems aren't going to come to you just as a simple 2 plus 1. They're going to come to you in the form of a problem that you're going to have to solve, and most of the time they're going to be multi-step problems, okay? So we're definitely going to take advantage of practicing some of these together and following some good steps that'll help us to become better problem solvers, okay? So we're going to be applying some of the knowledge that we've gained in this module so far, as far as it comes to like multiplication and addition and subtraction and all of those things. We're going to be putting a number of those skills to the test here as we attempt to do some problem solving. Now I'm going to give you the luxury of not turning on my camera today because I am all sweaty from all of those laps and miles and feet that Miss Walker is making me walk, so we can earn our points here, but we'll still be able to do some good problem solving together anyway. And you will have the wonderful stand-in of my Bitmojis here to keep you company, so maybe that'll keep you going. All right, so let's take a look at, first of all, the first thing I want to look at is like kind of a problem solving to-do list, if you will, or some notes or something to kind of keep in mind. And if you want to jot these down, it might not be a bad idea to put these like in your math binder or math folder or something somewhere, so you can kind of always think of these steps every time you come to a problem that you need to solve. So the first thing is it says to model the problem, okay? So can you draw something? What can you draw, and what conclusions can you make from your drawing? Now this one is my favorite step when it comes to problem solving. So after you've read the problem and reread the problem and you've kind of dissected it a bit and taken a look at the numbers, you want to model it. Just draw something out, okay? That's my biggest words of encouragement here. I know we've looked at the tape diagram before. That's a great place to start. But if you don't feel comfortable with that, just draw some circles, draw some rectangles, draw actual pictures of whatever it is it's asking you. Just get something down on paper. I know a lot of you guys are mental math geniuses, and that's fantastic. You can do a lot of these problem solving things in your head. But for these problems that we're getting into now, we have 2 or 3 or even 4 steps, and there's a lot of numbers going on. So if you can draw something out and map it out on paper, I guarantee you're going to have a better success rate than if you just try to do it all up here. Not saying you can't. I'm not saying that I don't want you to use mental math, but draw it out on paper, get it all mapped out, and then use the mental math. At least the paper will help guide you through where you need to go. Your drawing and your model will help you guide you through where you need to go, okay? So draw something out. And even if it's not right the first time, you're like, yeah, I don't like the way this is going, you can cross it out and do it again, okay? You have options here. And then usually, like to me, when I get it all mapped out, I'm like, okay, cool. Now I see where I need to go. I can just kind of, sketch something out, and it helps to kind of trigger in my mind what it is I need to do, okay? So model the problem, definitely an important step to keep in mind. The second one is to calculate, to solve, and write a statement. So we definitely want to figure out, what is the actual calculations that I'm going to have to do? What am I going to have to add or subtract or multiply? And what steps am I going to have to take to get there? And then once I do that, write a statement. So I could say, whatever the answer is, like 7,401 is how many baseball cards Mr. Walker has, or something like that. Put it into words so you really understand what that number is. You're not just saying it, you're not just picking a random number. This number means something, and this is what the number means. So that's what it means when we say to calculate and write a statement to solve. And then the last one is to assess the solution. So look at it and go, okay, does this make sense? Does this really fit into what we're doing here? Did I get a number that's like way above what my estimate was? Did I get a number that's way below it? Does it not even really fit the problem? If we're talking about how many marshmallows somebody can fit into their mouth, and I come up with a number that's like 2,065,000, well, I mean, I could probably fit that many marshmallows in my mouth, but realistically, that's going to be impossible. So does your a solution even make sense to what it is that you're trying to solve? So all of these things are things that you want to keep in mind as we're working through some problems and doing some problem solving, okay? So we have our good steps. We have strategies ready for us to go. So let's go ahead and jump into a couple problem solving solutions, or problem solving problems. And we're going to go through some of these steps together. Now, the problems we're going to go over are in your problem set for today's lesson, so you can follow along with me. You can have that out, or you can just write on a piece of paper and follow along with me. So make sure you have something to write on, something to write with, and then we'll go ahead and get started. All right, awesome. So let's take a look at the first problem here. All right, so this is a rather long problem. There's a lot of stuff going on, but you know what? It's okay. We're going to be able to figure this out. So this one says, Sylvia weighed 8 pounds when she was born. By her first birthday, her weight had tripled. Wow, okay, so tripled. I'm just going to highlight that for now. I got to remember what that word means, but I think it's going to be important, so we'll come back to that. By her second birthday, she had gained 12 more pounds. At that time, Sylvia's father weighed 5 times as much as she did. What was Sylvia and her dad's combined weight? Okay, so first off, I want to look at what the problem's actually asking me, right? What's my question? So here's my question here. What was Sylvia and her dad's combined weight? Okay, so let's go back through and pick out some information real quick. So I have that she weighed 8 pounds when she was born, and by her first birthday, her weight had tripled. Tripled means 3 times, right? If you triple something, you're multiplying it by 3. So that's what I wanted to remember. I knew that was going to be important. So that's another good number that we're going to need to know for that. Let's keep going on here. By her second birthday, she had gained 12 more pounds. So she's not tripling or doubling or timesing anything. She had just gained 12 more pounds. So that's going to be like adding 12, right? And then it says at that time Sylvia's father weighed 5 times as much. So 5 times. So it looks like I got some multiplication in here with my tripled and with my 5 times, and I have some addition with gained 12 more. And then they want to know the combined weight. So combined means to put things together. It's going to be another addition problem there. So we definitely got a couple operations going on here. We got some multiplication and we got some addition. Now we got to figure out, like, in what order do I have to do them all? What steps do I have to take, okay? So this is where that modeling piece comes in. This is where I'm going to draw something out and see if I can kind of visualize what's going on here, okay? And what I'm going to draw is going to kind of look like a tape diagram, but if you would rather draw this in circles or in squares or in something else, I don't really care, as long as you're drawing something and you're modeling it in some way. Yes, the tape diagram might be the preferred method, and it might be what we show you most of the time, but any kind of drawing, any way of getting out that information is going to be good, okay? Something is better than nothing, obviously. So let's go ahead and start sketching some stuff out. So let's see, she weighed 8 pounds when she was born. All right, so I'm going to draw a little square here, square rectangle type thing. And this is going to represent Sylvia when she was born, and she weighed 8 pounds, okay? So this we're going to say is her first birthday weight, right? I'm sorry, this is the weight when she was born was 8 pounds, but for her first birthday, her weight had tripled. So what is that 8 3 times, right? So this is 1, 2, 3. This would represent by her first birthday, right? So the total of these 3 would be how much she weighed on her first birthday. So what is 8 plus 8 plus 8, or 8 times 3? Right, that's going to be 24. Okay, so by the time her first birthday rolled around here, she weighed 24 pounds. Awesome, not terrible there. And it says by her second birthday, she had gained 12 more pounds. Okay, so what I'm going to do is I'm just going to rewrite this one more time just to make sure I'm following along with myself. So this is her first birthday where she weighed 24 pounds. Okay, and by the time her second birthday came around, she had gained 12 more pounds. So now I get to add on those 12 pounds, right? So all together, that's going to give us what? Awesome, 36 pounds. Okay, because 12 plus 24 is going to be 36. So by her second birthday, she weighed 36 pounds. All right, so I'm going to move some things around real quick just to get a better idea of what I have going. All right, so we have our weight from our first birthday plus the weight from our second birthday, which gives us a total of 36. So far we're good with Sylvia's weight. Okay, we're good with that. But that's not all we're looking for, right? We're looking of the combined weight between her and her dad's. Okay, so it says at that time Sylvia's father weighed 5 times as much as she did. 5 times as much as 36. So if we think about it this way, what I'm going to do is I made that a little bit smaller because I'm going to say that this is Sylvia's weight here. So this is going to be Dad's weight. Dad weighs 5 times as much, right? So there's 1, 2, 3, 4, and 5. 5 times as much, right? And each one of these rectangles represents the 36 pounds, right? 36 that Sylvia weighed on her second birthday. So 36, 36, 36, and 36. Perfect. So again, the question is asking us, what was Sylvia and her dad's combined weight? Could I figure that out now? What would the combined weight be? Or what would my next step be in order to figure that out? All right. A couple different ways I could take this next step, right? First, I could do 36 times 5, right? 36 times 5. So let's see, 36 times 5 would give us, well, 5 times 6 is 30. And 5 times, carry my 3 up here, and 5 times 3 is 15, plus 3 more would be 18. So this would be 180. And then I could add on Sylvia's weight, so 180 plus 36 would equal 6, 8, 9, 10, 11, and 216 pounds. So I could do it that way, right? So I could find Dad's weight first, 180 pounds, plus Sylvia's weight of 36 pounds, add those two together. Or, if I want to think of it this way, I really have 1, 2, 3, 4, 5, 6 rectangles that are worth 36 pounds, right? So what I could have done is 36 times 6. So 6 and 6 would be 36. Put my 6 down here, carry the 3. 6 times 3 would be 18, 19, 20, 21. 216. Either way, I would have got the same answer, okay? Either way is right. Doesn't really matter. Just 2 different ways to get there. So 216. So I have to think of that now. I have to take that number, and as according to what my next step was, is I have to kind of write that in a sentence that would make sense. Okay, so let me just make some more space for myself here. So I could say something to the effect of, combined weight is 216 pounds. So Sylvia and her dad's combined weight is 216 pounds. So I'm writing that as a statement because that's what my answer means. 216 pounds, well, what is that? If I hadn't already read and understood the question, I would have no idea what that meant. So to put it in some sort of a statement really kind of helps to drive home, like, this is what my answer is. Sylvia and her dad's combined weight is 216 pounds, okay? Perfect. So let me evaluate that for a second. Does that make sense? Okay, that's our third step here. Does it kind of fit into what we're doing? Well, given the average weight of a person, I myself weigh around 180 pounds, and we're talking about a 2-year-old baby. So yeah, I would say this fits. Now, if I had come up with a number like 600 and something pounds, I might be questioning that a little bit. If I had come up with a number like 75 pounds, I might be questioning that too. That seems a little low. The other one seems a little high. So you just want to look at it and go, okay, that makes sense. Does it kind of fit into my problem here? And this one does for sure. Okay, so it's a little bit of problem solving with this one. Definitely a lot of steps in this, okay, but nothing that we couldn't do. All things that we knew how to do. We know how to multiply a 2-digit number by a single-digit number. We know how to add and subtract multi-digit numbers, right? We know how to combine different things and put things together. It's really just breaking down exactly what that question is asking us to do, which we were able to do here. So perfect. Let's try one more together, and then I think you guys are going to be up for some problem solving on your own. All right, here's our second problem here. It says in 1 month, Charlie read 814 pages. In the same month, his mom read 4 times as many pages as Charlie. Right there, that's jumping off at me or jumping out at me because of the times, right? That means multiplication, so that's good. So let's keep going. And that was 143 pages more than Charlie's dad read. 143 pages more. That sounds to me like that could be addition or subtraction, right? So let's just underline it for now, but we'll wait and come back to it. What was the total number of pages read by Charlie and his parents? All right, so what the question is actually asking us is what was the total number of pages read by Charlie and his parents? So we want to know like all together, how many did the whole family read, right? But the only one that I know exactly how much they read was Charlie. Charlie read 814 pages. That's it. I don't know about everybody else, but I can figure them out as long as I do some math to get there. So I'm going to start to map this out a little bit. I'm going to start to model it, to draw it, and to see what I can figure out, what steps we might need to take to get to our answer. So I'm going to start by drawing a box here to represent how many pages Charlie read. So let's see. He read 814, right? Okay, cool. So this is Charlie. This is what he read. Now, if you wanted to draw a book, if you wanted to draw a circle, if you wanted to draw something else, like that's totally fine. I'm going to just draw a rectangle because it's easy and I don't want to spend too much time just drawing a neat, intricate little picture because then I might not actually have time to get my work done to solve the problem. All right, so here's Charlie. He read I did that twice now. He read 814 pages. Next, it says his mom read 4 times as many pages as Charlie. So, let's write mom right here. So that means mom read 1, 2, 3, 4 times as much as Charlie did, right? That's what it says in the sentence up here. She read 4 times as many pages as Charlie. So I would just have to do what Charlie read 4 times. Okay, easy enough. Now this says at last here that it was 143 more pages than Charlie's dad read. Okay, so Charlie's dad read pretty close to mom, but he was only 143 pages less than her. So I'm going to come down here, I'm going to put a D for dad, and I'm going to do something similar to mom. Right, 2, 3, 4, but Charlie's dad read, let's see, 143 pages. Well, it says that his mom read 4 times as many pages as Charlie. That was 143 pages more than Charlie's dad. So Charlie's mom read more than Charlie's dad, and it was about 143 pages more. Okay, so basically, dad didn't read quite as much as mom did. He read less, okay? So I'm going to go ahead and sketch that in and say it was about 143 less, right? Which is what we have here. Okay, and this was kind of tricky the way they phrased this, right? 143, if I were to just glance at this again real quick, 143 more pages. Oh, okay, so he read 143 more. But that's not quite what it's saying. It's saying that mom read 4 times as many as Charlie, and that was 143 pages more than Charlie's dad. So she read this much more than Charlie, and she read 143 pages more than dad. So again, you really got to be careful when we read these problems. Read them, reread them, make sure it makes sense, and take your time with it, okay? So now that I have all this sketched out, basically what I want to find is, what is this total? Because this total is going to be, I'm just going to put an F for family. This is going to be for the whole family to be able to figure out what they read, okay? And having these squares in here and everything definitely helps me to kind of lay things out and see what I have to do. And I know the first thing I'm going to have to do is I'm going to have to figure out what this number is, 814 times 4. Then I'm going to have to figure out dad's, and then I'm going to have to add all of them together, okay, to get that total of how much everybody read, all right? So let's get down to business. So why don't you go ahead and tell me what your first step is going to be and what the answer is. All right, so my first step was I took this 814 and I multiplied it by 4 because I have 4 of them, right, to try to find out how many pages mom read. So I did 814 times 4, and that gave me 3,256. So that's how many pages that mom read. Okay, so from here to here is 3,256. Now I'm going to find out what dad read, because he read 143 pages less than mom. So if I take that 3,256 and I subtract 143, that should tell me how many pages dad read. Okay, so let's see, 3 from 6 is 3, 1, 1, 3. So that means that dad read 3,113 pages, okay? Because it's the amount of pages mom read minus that 143. So now we know what Charlie read, we know what mom read, we know what dad read. So what would be our next step? Perfect, we could add up all of those numbers. So I'm going to have to add up, give myself some more room to work here, but I'm going to have to add up 814 plus 3,256 plus 300 plus 313. So if I add all these up, I'll get 4 and 6 is 10 plus 3 more, give me 13. 1, 2, 3 plus 5 would give me 8. 8 and 2 is 10 plus 1 more is 11. And 3 and 3 is 6 plus 1 more is 7. Wow, 7,183. Now let's put that into a statement, right? So it makes sense. So we could say Charlie and his family read 7,183 pages. That's a lot of pages. Good for them. So we saw the way that I solved the problem, that I had my 814, and then I did 814 times 4 plus 814 times 4 minus 143. So that's one way we could have gotten to the answer there. Is there another direction I could have taken? Another way I could have solved the problem? Yeah, actually, another way I could have done it was I could have thought of this as 1, 2, 3, 4, 5, 6, 7, 8, 9. 814 pages, right? Looking at like the rectangles and stuff I drew here, I could have thought of 814 times 9, and that would have given me, let's see, 9 times 4 is, so I would have gotten 7,326, but what I would have had to have done is then subtracted that 143, if we subtract that out, we would be left with 7,183, which is the same answer. So 2 different paths we could take to get there, but we're going to get the same answer either way. And again, looking at this to kind of think about its reasonableness, Charlie read 114 pages in a month. That doesn't seem too far out of it. And his parents reading 4 and 5 times more than him, definitely feasible. Parents sometimes tend to read a little bit more than their kids. I wish I had more time to read than my kids, but right now it seems like they're having more time to read than me. But again, this isn't like out of the ordinary. If we had been in like the million or 2 million or 3 million mark, we might have said, hey man, I made a mistake somewhere. But I think this is reasonable for what we're doing. So hopefully this helps get you guys in the right path and some problem solving. There's some more problem solving for you guys to do in your problem set and in what you're going to practice throughout the day. So hopefully this helps, and if you have any other questions, comments, or concerns, guys know how to find me. Please reach out, let me know. I'd be more than happy to help. But you guys got some good problem-solving skills out there, so I want to definitely see them put to the test, okay? All right, guys, thanks. We'll talk to you soon. All right, guys, this is as far as I made it. Done with the whole walking thing, but hope you guys got some good problem-solving skills going now and got some strategies that you could use, because I could really use your help. So, as I said, I've walked 287 yards today. I walked 287 yards yesterday. Miss Walker, she claims to have walked 3 times as much as I have, and we need to make it to that 5,280 yard mark. That's what we're looking for, right, to meet this next fitness challenge. So if you could tell me how many more yards I've gotten, that would be awesome. And it looks from here I've probably got like about 326 yards till I get home. So if you want to add that into the mix, 326, and figure out like how many more altogether do we have to get, that would be greatly appreciated, because I've just run out of steam. I'm gonna lay down here on the sidewalk for a bit, take myself a nap, and then hopefully get up and get back home before Miss Walker starts to worry in her 3 times as many yards. So anyway, guys, have a good one. Thanks for watching, and we'll talk to you soon.